Hello, welcome to this episode of Pathology Mini Lecture. The title of this episode is The Vascular Phase of Acute Inflammation. The local clinical signs of acute inflammation are hotness due to increased blood flow, redness due to dilation of small blood vessels within the damaged area, swelling due to edema, pain and tenderness, and loss of function. All these signs are caused by changes in the microcirculation, changes in the vascular permeability with formation of fluid exudate, and the changes leading to the formation of cellular exudate. In this episode, we'll discuss the first 2 points, while the third point will be discussed in a separate video. Let's begin with the changes in the microcirculation by defining what is the microcirculation and what is microvasculature. The microvasculature lies between the terminal arterioles and postcapillary venules. It comprises the capillary network and an anastomosing vessel between the respective arteriole and venule. The blood vessel has a certain diameter, and the blood flows in the middle of its lumen at certain speed. This is called central axial stream, which contains RBCs, platelets, WBCs. WBCs are present at its periphery. The blood vessels are lined with endothelial cells with gaps in between them. The central axial stream is separated from the endothelium by a layer of peripheral plasma zone. The changes include changes in the vascular caliber, changes in the blood flow, and changes in the endothelium. Now, let's start with the changes in the vascular caliber. Changes in the vascular caliber pass through 3 phases: early vasoconstriction, followed by persistent vasodilation with dilation of postcapillary venules, and lastly vasodilation with constriction of postcapillary venules. Let's start with transient vasoconstriction of the arterioles. It occurs due to direct effect of injury on the muscle layer of the blood vessel wall and also due to release of serotonin. Serotonin is a powerful vasoconstrictor. It's released from platelets and mast cells. It appears in the early phase of inflammation and it stimulates smooth muscle contraction. Transient vasoconstriction prevents further spread of harmful agents. It results in brief paling of the inflamed area. Besides its direct effect on the vessel wall, injury leads to damage of cells. These damaged cells stimulate the release of chemical mediators. Not only this, but also injury leads to activation of local action reflex, resulting in a flush, a flare, and wheal. So the net result of injury is that through its direct effect, through release of chemical mediators, and through activation of local action reflex is vasodilation. Transient vasoconstriction is followed by persistent vasodilation of precapillary arterioles, capillaries, and postcapillary venules. This occurs under the effect of histamine released primarily from mast cells, also from basophils and platelets, platelet activating factor released from platelets, and kinins and nitric oxide and prostaglandins, or are very powerful vasodilators. Vasodilation helps in flushing out the harmful agents. It results in erythema, swelling, and pain in the inflamed area. The third phase of changes in the microcirculation begins several hours after the onset of inflammation and lasts for a period of several hours. It's brought about by vasodilation of capillaries and arterioles and is accompanied by vasoconstriction of the venules. This vasoconstriction slows the circulation, elevates filtration pressure, and also it increases vascular permeability in the inflamed area. Changes in the blood flow. The blood flow is initially rapid due to vasodilation. This leads to hotness and redness and increased local hydrostatic pressure and early formation of exudate. The initial rapid flow is followed by slowing of blood flow. Slowing of blood flow occurs due to increased vascular permeability, which results from formation of the endothelial gaps due to contraction of the endothelial cells, direct injury of the endothelial cells in severe injury, and also due to difference in pressures across the vessel wall. All these will result in increased vascular permeability, which leads to outpouring of protein-rich fluid. This will lead to increased blood viscosity and also concentration of RBCs, forming what is known as red sludge. The increased concentration of RBCs besides increased blood viscosity will lead to slowing of blood flow. Changes in the endothelium. Contraction of the endothelial cells under the effect of histamine, leukotrienes that cause cytoskeletal proteins to contract. Contraction of the endothelial cells leads to opening of the endothelial gaps. Also, the surface of the endothelial cells become more adhesive to white blood cells, as a very important step in formation of cellular exudate, and it will be explained in details in the next video. Now, changes in the vascular permeability. Increased vascular permeability results from contraction of the endothelial cells to form what's known as endothelial gaps, also due to direct injury of the endothelial cells in severe inflammation, and also due to difference in pressures across the vessel wall. All these will lead to increased vascular permeability. Now let's go to more explanation about differences in pressures across the vessel wall in the next slide. Normally, the hydrostatic pressure in the microcirculation is higher at the arterial end than at the venous end. With increased blood flow, the intravascular hydrostatic pressure increases, especially at the venous end. This will lead to outpouring of protein-rich plasma from the blood vessel to the interstitial tissue. This will lead to decreased intravascular osmotic pressure. At the same time, all these both proteins will lead to increased tissue osmotic pressure. So with the continuation of this process, at the end we have decreased intravascular osmotic pressure and increased tissue osmotic pressure and formation of fluid exudate. So to sum up and simplify this process, we have increased blood flow leading to increased hydrostatic pressure, loss of proteins from the capillaries leading to decreased plasma osmotic pressure, and increased proteins in the interstitial tissue leading to increased tissue osmotic pressure. So the net result of increased hydrostatic pressure plus decreased plasma osmotic pressure plus increased tissue osmotic pressure is formation of fluid exudate. The process of exudation is the escape of fluids, proteins, RBCs, and WBCs from the intravascular space into the interstitial tissue. This process has many advantages. So the advantages of fluid exudate are: increased fluid leads to dilution of toxins. Number two, increased proteins, especially globulins, which are antibodies against foreign antigen, and also fibrinogen, which transforms into fibrin, which acts as barrier against spread of infection, cement to unite injured tissues, surface to enhance phagocytosis, and also as a scaffold to help in repair. At the end, to sum up the changes of acute inflammation, we have changes in the microcirculation, changes leading to the formation of fluid exudate, changes leading to the formation of cellular exudate. Changes in the microcirculation include changes in the vascular caliber, changes in the blood flow, and changes in the endothelium. Changes in the vascular caliber include early vasoconstriction followed by late persistent vasodilation. Changes in the blood flow, early rapid flow followed by late slow flow. Changes in the endothelium include contraction of the endothelial cells with opening of endothelial gaps, and also increased surface adhesiveness of the endothelial cells to white blood cells. Alright, thanks for watching. I hope you enjoyed this video. Until I see you next time, bye bye.